Why is the sun essential for weather?
Our sun is the source of almost all of the energy that creates weather on the planet, plate tectonics. The heat within the Earth, tidal effects, radioactive elements, and the effects of gravity from Jupiter and Saturn provides the rest. The majority of the energy, 99.98%, is from the sun, however. Although the amount of light, heat, and other energy from the sun that hits the Earth is equal to only 5 × 10⁻¹⁰ of its total output. This is still the equivalent of burning 700 billion tons of coal every day. It has also been calculated that the energy reaching Earth's upper atmosphere is equal to 5 million horsepower per square mile. That's enough to rev up the engines of 7,400 Indianapolis 500 race cars. Planet-wide, that would be about 14.5 billion race cars being powered up daily by the sun. If the sun's energy on the planet's surface was constant, it would not affect weather. This is not the case. Because our planet spins, giving us day and night, and tilts, giving us the seasons, the energy is not distributed evenly. Also, clouds and variations in the upper atmosphere affect solar energy levels. The result is that Earth is covered with areas of colder and warmer air, causing air masses to move, which are, in turn, diverted this way and that by variations in geography and the Coriolis effect. This is what gives us the weather.
How much carbon dioxide is being produced by cars and industrial emissions in the United States?
A 2004 study from the Environmental Protection Agency noted that total emissions from 1990 to 2004 have increased by 15.8%. While this is not great, when compared to an increase in the U.S. gross domestic product of 51% over the same period, it is a somewhat controlled increase.
What is a thermoscope and who invented it?
The history of the thermometer goes back to the ancient Greeks. It is not known exactly who invented a working thermometer, but the earliest record has Philo of Byzantium creating what was called a thermoscope back in the 2nd century BCE. Similarly, crude devices using the expansion of water due to temperature were used throughout the centuries. The prolific Renaissance inventor and artist Galileo Galilei, 1564 to 1642, improved the air thermoscope in 1593. The thermoscope he created uses a different approach to measuring temperatures than the thermometer. Instead of containing a fluid, such as mercury, that is sensitive to changes in heat and cold, the thermoscope suspends several objects within a transparent tube.
What is a bear's cage?
The region of heavy rain and hail that usually forms on the southern and western side of a mesocyclone. But to the northeast of where a tornado may exist or may be forming, is referred to by storm chasers as the bear's cage. This is the most dangerous part of the storm, as a tornado can be obscured behind a rain shield, striking with little warning. Visibility is low, and damaging hail, strong winds, and flash floods are also a hazard.
Does air pollution reach as far as the North Pole?
Yes. Winds can carry air pollutants far beyond the Arctic Circle, resulting in a condition called Arctic haze. The pollution tends to be worse during winter and spring, when prevailing winds from northern Europe to Siberia blow emissions northward from industrial areas. Recent shifts from coal burning to natural gas, primarily from Russia, has created cleaner air conditions, fortunately.
What is global warming?
Global warming and the greenhouse effect are not necessarily the same thing. While the greenhouse effect can cause global warming, other things can lead to the planet warming or cooling. Other factors include changes in geography, plate tectonics, and cycles of the Earth's orbit around the Sun. It is known that global warming is necessary to a certain point, without the ability of certain gases in the Earth's atmosphere to help retain radiation from the Sun, our planet would be a cold ice ball in space. These gases act like the glass of a greenhouse, thus the name greenhouse gases, trapping much of the energy emitted from or bounced off the ground and keeping our world warm. This, in turn, allows organisms, plants, animals, and otherwise to live. More recently, global warming has been used to describe the unnatural increase in the average surface temperatures around the world. Many scientists, and others, believe humans have pumped excess amounts of greenhouse gases, such as carbon dioxide, methane, and nitrogen oxides, into the atmosphere, causing temperatures to rise. Something has already raised the surface temperatures about 0.5 degrees Celsius 1 degree Fahrenheit. In the past 100 years, and scientists believe it to be human-induced.
Where is the rainiest place on Earth?
The wettest place in the world, in terms of total rainfall, is Mawzinram, India, which drowns in 468 inches, 1,188 centimeters, of rain each year, mostly because of monsoon rains. Nearby is Cherrapunji, India, which receives 460 inches, 1,170 centimeters, of rain. Second place, though, goes to Tutunundu, Colombia. Here, the average annual rainfall is 463.4 inches, 1,177 centimeters. Unofficially, Lareau, Colombia, endures 523 inches, 1,328 centimeters of rain annually, but no verified measurements have been taken to confirm this claim.
So, what is the modern theory of plate tectonics?
The Earth's crust and lithosphere are broken into over a dozen thin, rigid shells, or plates, that move around the planet over the plastic asthenosphere in the upper mantle. The interaction between these plates is called tectonics. From the Greek tekton for builder, plate tectonics describes the deformation of the Earth's surface as these plates collide, pass by, go over, or go under each other. In other words, plate tectonics describes how these plates move, but not why. Overall, plate tectonics combines Wegener's theory of continental displacement, or drift, and Hess's discovery of seafloor spreading, sea below. The theory has truly revolutionized the study of the Earth's crust and deep interior. It allows scientists to study and understand the formation of such features as mountains, volcanoes, ocean basins, mid-ocean ridges, and deep-sea trenches, and to understand earthquakes and volcano formation. It also gives clues as to how the continents and oceans looked in the geologic past, and even how the climate and life forms evolved.
How far can a dust storm travel?
Central Asia and China have annual dust storms in their desert areas almost every April. And the dust from these storms has been known to reach as far away as Hawaii. On the other hand, dust storms from Africa have blown dust all the way to Florida. Blowing dust can actually be a good thing, as it helps distribute soil nutrients around the planet. For example, it is known that rainforest soil in the Amazon is replenished from African soil, as is soil in the American Southeast.
What is syzygy?
Syzygy occurs when the moon and sun are aligned, an event that happens twice monthly. The effect on Earth is that the gravitational pull of these two space bodies is strengthened, increasing the elevation of high tides and decreasing low tides.
What is a rainbow?
Rainbows are colorful bands of light that are formed when water particles in the air reflect sunlight. As sunlight enters the drops and droplets, the different wavelengths of colors that compose sunlight are refracted at different wavelengths to produce a spectrum of color. To see a rainbow, you must be standing with the sun behind you and the raindrops in front of you. The sun needs to be less than 42 degrees above the horizon to obtain the correct angle so that the light waves are properly reflected. The light is refracted as it enters a raindrop, reflects off the inside of the back of the raindrop, and is refracted again as it leaves.
Why do sunspots appear dark?
Sunspots are a slightly cooler temperature, about 2000 degrees Fahrenheit 1100 degrees Celsius cooler than their surrounding photospheric gas, and so in the bright backlighting, sunspots appear dark. Do not be fooled, though, a sunspot is still many thousands of degrees. And the amount of electromagnetic energy that courses through sunspots is tremendous.
What chemicals are used in thermometers?
The two liquids that are typically used in a thermometer are mercury or alcohol. The alcohol in thermometers is dyed red to be easier to read, while mercury has a silver color. Both liquids work well in determining temperature, but alcohol thermometers are safer. Should a mercury thermometer break or leak, the liquid metal inside could evaporate and the fumes are toxic. Also, mercury tends to expand or contract more slowly than alcohol. Mercury, furthermore, can't measure temperatures below -38 degrees Fahrenheit. -38.9 degrees Celsius, because that is the point at which it turns into a solid. The disadvantage of alcohol, however, is that it tends to evaporate or polymerize over time.
What is LiDAR?
You can think of LiDAR as being the equivalent of a light radar. Meteorologists can use laser beams pointed at the atmosphere to measure such things as pollution concentrations and wind velocity.
Do oceans get more rain than land?
The oceans receive just over their share, percentage-wise, of the world's precipitation, about 70%. The remaining 30% of precipitation falls on the continents. Some areas of the world receive far more precipitation than others. Some parts of equatorial South America, Africa, Southeast Asia, and nearby islands receive over 200 inches, 500 centimeters, of rain a year, while some desert areas receive only a fraction of an inch of rain per year.
What does a 40% chance of rain really mean?
When the morning weather report speaks of a 40% chance of rain, it means that throughout the area, usually the metropolitan area, there is a 4 in 10 chance that at least 0.001 of an inch of rain, 0.0025 centimeters, will fall on any given point in the area.
What was the Great Hurricane of 1938?
Possibly the worst storm to ever hit the American Northeast since the arrival of Europeans. The Great Hurricane of 1938 wreaked havoc throughout New England and down as far as Long Island. 600 people died as a result of the storm in what has also been called the Long Island Express.
What is the current extent of deforestation?
Worldwide, we are losing enough forest land annually to cover an area the size of the state of Panama. To put that figure into numbers, that is a net loss of 7.3 million hectares, 18 million acres, every year. Actually, about 13 million hectares, 32 million acres, are being chopped down yearly. But there are restoration projects going on that help replant forests. This rate of loss, which is an average taken from the years 2000 through 2005, is somewhat better than the 8.9 million hectare, 22 million acre, loss that was experienced during the previous decade. Although replanting is great, new forest growth does not make for as healthy a habitat for wildlife as old forest growth.
How do radars use the Doppler effect to measure the weather?
Doppler radar, unlike conventional radar systems that could only indicate where a storm was and how intense it was, can be used to detect wind speed and the direction storms are taking. Because one Doppler radar can only tell if a storm is heading away or toward it, a network of radars is needed to chart a storm's precise course.
How is wind direction usually measured?
A wind vane is the common instrument used to discover wind direction. Wind vanes look like windmills mounted on a pole that allows them to rotate toward the direction of the oncoming wind. Historically, wind vanes have often come in decorative models, often with a rooster or some other farm animal mounted on the top. Of course, there are many other ways to discover wind direction, ranging from the primitive analyzing the direction smoke is blowing or how balloons are moving, to the more sophisticated, such as Doppler SODAR, sound radar, and LiDAR, light radar. Gyroscopes and GPS devices mounted in airplanes can calculate airspeed by comparing the indicated speed to the actual distance covered, i.e., the amount of thrust from the airplane's jets or propellers may be slowed or sped up, depending on whether winds are blowing with or against the plane.
Which country produces the most greenhouse gas?
This dubious honor used to belong to the United States. The economic boom in China, however, has led to a corresponding surge in pollution. While, per capita, Americans still cause more pollution. There are 4 times as many Chinese as Americans. A 2007 study published by the Netherlands Environmental Agency noted that Americans produce about 20 tons, 18 metric tons, of carbon dioxide emissions per capita, versus 5 tons for each Chinese citizen and about 10 tons, 9 metric tons, for each European. Industrialized nations emitted about 16.1 tons, 14.6 metric tons, of greenhouse gases per capita versus about 4.2 tons, 3.8 metric tons, per capita for those living in developing countries. The study also noted that if the increase in greenhouse gases is not halted within 10 to 25 years, the planet will experience a runaway greenhouse effect with average temperatures rising several degrees Celsius, causing ice caps to melt and coastal regions worldwide to become flooded.
What is the eye of a hurricane?
The eye of a hurricane is a region of relative calm in the middle of the swirling storm. Hurricane eyes range in size from 4 to 40 miles, 7 to 74 kilometers, in diameter. Although Hurricane Wilma had an eye only 2 miles 3.2 kilometers wide, and can be so free of clouds that sunshine can be seen. The more intense the hurricane, the smaller the eye tends to be. The eye is surrounded by the eye wall. An apt phrase because it is literally a circular wall that can reach 7 miles, 11.3 kilometers, into the sky. Once past the eye wall, the hurricane resumes. With winds blowing as fast as 150 miles per hour, 278 kilometers per hour, or more.
Why is there a hole in the ozone layer?
The ozone layer is not evenly distributed around the planet. It is thicker around the equator and nearby latitudes and thinner as one progresses north and south. This is true of the Earth's atmosphere in general because the planet's spin causes the planet to bulge slightly around the middle. The gravitational pull is consequently a little weaker and the atmosphere thickens. At the poles, the atmosphere is thinner, including the ozone layer. In addition, because ozone is dependent upon the interaction of sunlight and oxygen, there is naturally less ozone at the poles. Furthermore, ozone layers fluctuate naturally over time due to numerous factors affecting climate and sunlight levels. Since 1975, scientists believe that more than 33% of the ozone layer has disappeared. There is a seasonal factor to the reduction in ozone at any given time during the year, too. At different times, the ozone layer naturally declines or rises. But scientists also know that chlorofluorocarbons, CFCs, which are used for air conditioning, aerosol sprays, and halon in fire extinguishers, along with methane, CH4, and nitrous oxide, NO2, are broken down by UV radiation, freeing carbon, chlorine, and nitrogen atoms that then react with ozone molecules and destroy them. CFCs are particularly bad because they last so long in the atmosphere. One CFC molecule can destroy 100,000 molecules of ozone.
What is orbital inclination?
Not only does our planet tilt back and forth and wobble while it's doing it, but it also ranges up and down relative to the invariable plane, the plane. In simplified terms, passing through the solar system's center of mass. If you imagine the Earth's orbit as forming a disk like a CD, then imagine the CD wobbling back and forth instead of spinning on a level plane. Formed by the invariable plane, then you might get the idea of orbital inclination. The current orbital inclination of the Earth causes it to pass through the invariable plane in early January and early July. The invariable plane carries with it more space dust and debris than is found above and below this plane. Thus, as the Earth passes through the invariable plane, the atmosphere comes in contact with more space dust, which means we see more meteor showers and meteorites. The space dust also contributes to cloud formation in the upper atmosphere, noctilucent clouds.
How destructive was the blizzard of 1996?
The blizzard of 1996 left a path of destruction from Georgia to Pennsylvania. Almost $600 million in insurance claims were filed and 187 people lost their lives. 2 or more feet of snow covered Washington, D.C., West Virginia, New England, and New York City. In addition, about $700 million in flood damage was reported in Pennsylvania. Altogether, this one storm cost $3 billion.
Does all precipitation reach the ground?
No. Rain and other precipitation can often evaporate before reaching the ground, especially when the air is dry, low humidity. In the American Southwest, dry storms can be quite common, creating lightning and thunder but little precipitation. The danger of evaporating rain is that it can create conditions conducive to downdrafts and microbursts by cooling the air and causing changes in air pressure. Dry storms thus signal a warning to aviators about potential flying hazards.
What is the best weather for maple syrup to be produced?
Maple syrup harvesters wait until nighttime temperatures dip below freezing, while day temperatures are above freezing. The conditions are ripe for the sap in maple trees to flow best.
What will happen when Earth's magnetic field flips upside down?
Probably not much will happen to our daily lives when Earth's magnetic field undergoes a polarity reversal. Measurements over the years show that there has been about a 6% reduction in the strength of Earth's magnetic field in the past century. So some scientists think that a polarity reversal on Earth will likely happen sooner rather than later. Some non-scientific hypotheses have been put forth, suggesting that there will be an environmental catastrophe as a result. There is no scientific reason to believe, however, that such disasters will occur.
What is a steam devil?
In the Arctic, and, less often, Antarctic, or any other place where conditions are right, cold air passing over warm areas of water can cause steam to rise. And when a whirlwind sweeps in at the same time, this steam or fog forms small steam devils.
Is our climate changing?
Human lifespans, when compared to geologic time, are extremely brief. And so it is hard for us to imagine our planet's climate being much different than it is today. The fact is that over thousands and hundreds of thousands of years the Earth's climate has experienced wide fluctuations, ranging from the snowball Earth of about 635 million years ago to the extremely warm conditions, 18 degrees Fahrenheit, or about 8 degrees Celsius warmer, on average, than today, of a 100 million years ago when dinosaurs were flourishing. Over the millennia, there have been many periods of hot and cold. In the past, these have been caused by a variety of factors, ranging from volcanic activity to plate tectonics to the possibility of an asteroid crashing into the planet. Today, scientists fear we are undergoing a new and dramatic climactic change with one important difference: they believe humans are causing it.
Why is it wetter on one side of a mountain range?
It's much more wet on one side of a mountain than the other, because of a process known as orographic precipitation. Orographic precipitation causes air to rise up the side of a mountain range and cool, creating precipitation and storms. The storms deposit a great deal of precipitation on that side of the mountain and create a rain shadow effect on the opposite side of the range. The Sierra Nevada mountains are an excellent example of orographic precipitation. because the mountains of the western Sierras receive considerable rainfall. Far more than California's Central Valley, while the eastern Sierras of Nevada are quite dry.
What methods have been used to try to remove hazardous fog?
Helicopters have been used in the past to try and blow away fog. And in France people have used jet engines at airports to heat up the air. Both of these methods are very impractical, however.
What is a certified consulting meteorologist, CCM?
The American Meteorological Society, AMS, grants the title of CCM to professional meteorologists who have both broad experience in meteorology and a highly specialized knowledge of particular fields on which they intend to consult. In addition to education and experience, a meteorologist has to demonstrate professional conduct and service to be named a CCM. They are sought out by law firms, governments, law enforcement agencies, insurance companies, and other private businesses for their expertise and for the assurance that all CCMs will provide reliable and authoritative information. Only about 5% of AMS members are CCMs. The AMS provides a listing of CCMs by specialty on its website at http://www.aimtsoc.org.
What are some of the most unusually hot temperatures experienced in the United States?
People sometimes fret about global warming when they experience an unusually warm day in winter or early spring. But very warm days during colder months are not unheard of and have been recorded since at least the early 20th century. For example, some atypical January temperatures include 84 degrees Fahrenheit 29 degrees Celsius in Los Animas, Colorado. In 1916, 79 degrees Fahrenheit 26 degrees Celsius in Choteau, Montana. In 1919, and 82 degrees Fahrenheit 28 degrees Celsius in Indianola, Nebraska. In 1894. More recently, in January 1997, Zapata, Texas, had a record 98 degrees Fahrenheit 36.7 degrees Celsius, and on March 31, 1998, Baltimore, Maryland, reached 97 degrees Fahrenheit 36.1 degrees Celsius, and Concord, New Hampshire, saw 89 degrees Fahrenheit 32 degrees Celsius. Probably the hottest December day recorded in North America was in La Mesa, California, which saw the thermometer climb to 100 degrees Fahrenheit 37.8 degrees Celsius.
Is it possible to fry an egg on the sidewalk?
Well, not really. concrete sidewalks are not actually the best place to cook an egg. Not to mention they aren't very sanitary. On very hot days, the sidewalk temperature can get to about 145 degrees Fahrenheit. 62.8 degrees Celsius, but an egg requires about 158 degrees Fahrenheit 70 degrees Celsius to cook thoroughly. On the other hand, if you put an egg on blacktop, you are more likely to be successful because the black surface will absorb more heat. Even better is using a metal surface. And people have been known to cook an egg on the hood of a car on a summer's day.
Who invented the barometer?
Invented in 1644 by Evangelista Torricelli, 1608 to 1647, a barometer is a device for measuring air pressure. Torricelli was a student, for a brief 3 months, of Galileo Galilei, 1564 to 1642. And he was inspired by his mentor's observation that piston pumps can only lift water up 33 feet. About 10 meters, after which point it is impossible to pump the water any higher. After Galileo died, Torricelli continued to build on this observation. He theorized, correctly, that air had weight and, therefore, exerted pressure. He tested his theory by filling a dish with mercury. He used mercury because it was denser than water and therefore would require a much smaller amount to indicate pressure changes. He then took a 4-foot-long glass tube that was open on one end, filled it with mercury, and turned it upside down with the open end beneath the surface of the mercury. Some, but not all, of the mercury exited the tube. 30 inches, 760 millimeters, remained. This meant that the remaining mercury in the tube stayed in the tube because air in the atmosphere was exerting pressure on the surface of the mercury in the dish. Not only did this experiment prove Torricelli's theory that air had pressure, but he was also the first to create a vacuum, now called a Torricellian vacuum. The word barometer, which means weight measure, was not coined until 1665 by Irish scientist and theologian Robert Boyle, 1627 to 1691. Boyle came up with a new design for the barometer in which a U-shaped tube was used, eliminating the need for a mercury reservoir. English physicist Robert Hooke, 1635 to 1703. Made another improvement on the barometer by creating an easy-to-read dial display.
How many volts are in lightning?
A bolt of lightning discharges between 10 and 100 million volts of electricity. An average lightning stroke has 30,000 amperes. How long is a lightning stroke? The visible length of the streak of lightning depends on the terrain and can vary greatly. In mountainous areas, where clouds are closer to the ground, the flash can be as short as 300 yards, 273 meters, whereas in flat terrain, where clouds are higher above the ground, the bolt can measure as long as 4 miles, 6.5 kilometers. The typical length is about 1 mile, 1.6 kilometers. But streaks of lightning up to 20 miles, 32 kilometers, have been recorded.
What is heat exhaustion?
When the temperature is too high and people do not drink enough fluids, exert themselves too much, or spend too much time in the direct sunlight, heat exhaustion can result. Symptoms can include weakness, cold and clammy skin, paleness, fainting, irregular heartbeat, and vomiting. In extreme cases, heat exhaustion has been known to kill. There have been a number of cases where people exercising at a sports practice or conducting drills in the military have collapsed and died. Seniors and people who are already ill are particularly susceptible to heat exhaustion.
Who invented the device to measure humidity?
The hygrometer, which measures humidity in the atmosphere, was invented by the French physicist Guillaume Aumont-Tons, 1663 to 1705.
Can volcanic eruptions affect the global climate?
Most volcanic eruptions do not affect the global climate, although larger ones can cause disruptions, albeit for a relatively short period of time. Large eruptions tend to eject gases and dust high into the stratosphere. From there, prevailing winds carry the particles around the world, sometimes with interesting results. For example, in 1815, Mt Tamborat on the island of Sumbawa, near Java, Indonesia, erupted, putting out a record amount of ash that briefly changed the world's climate. Huge amounts of volcanic dust rose high into the atmosphere, reaching around the globe. That year, and for some of the following year, volcanic particles screened out some sunlight, causing the global temperatures to fall. In Europe and other parts of the northern hemisphere, winter never seemed to end, with frosts occurring throughout the summer. Hence, 1816 is known as the year with no summer. Scientists used to believe that cooling of the atmosphere could result from volcanic eruptions because of the amount of ash that was thrown up into the air. Now they know, however, that most of these fine particulates return to the Earth within about 6 months. What actually has a greater effect is the sulfur dioxide, SO2, that volcanoes produce. Sulfur dioxide reacts with water vapor, and the result is a long-lasting haze that blocks out a considerable amount of the sun's radiation.
How often does an aurora appear?
Because it depends on solar winds and sunspot activity, the frequency of an aurora cannot be predicted. Auroras usually appear 2 days after a solar flare, a violent eruption of particles on the sun's surface, and reach their peak 2 years into the 11-year sunspot cycle.
What are umbrophobia and hamarchiophobia?
Umbrophobia is an irrational fear of the rain, while hamarchiophobia is a fear of fog.
Who contributed to early work in plate tectonics?
There were several key scientists who contributed to the study of plate tectonics as it became more favored in the late 1960s. One of the most popular scientists to discover evidence for plate tectonics was J. Tuzo Wilson. 1908 to 1993, by 1965, he described the origin of the San Andreas Fault, the large crack in the Earth's surface near San Francisco, California, as a transform fault, or strike slip, one of the major plate boundaries. In 1968, Xavier Le Pichon, 1937, participated in the definition of the overall plate tectonics model and published the first model quantitatively describing the motion of 6 main plates at the Earth's surface. In 1973, he wrote the first textbook on the subject. Other geologists have made major contributions to the development of the plate tectonics theory. William Jason Morgan published a landmark paper in 1968 explaining the many tectonic plates and their movements. He also recognized the importance of midplate volcanic hotspots that create island chains such as the Hawaiian Islands. Walter Pittman III was instrumental in interpreting the pattern of marine magnetic anomalies detected around mid-ocean ridges, an indicator of active seafloor spreading and evidence of plate tectonics. And Lynn R. Sykes used seismology to refine plate tectonics. And he noted the connection between transform faults at the mid-ocean ridges and plate motion. He also co-authored Seismology and the New Global Tectonics in 1968, which relates how existing seismic data could be explained in terms of plate tectonics.
Has a hurricane ever made landfall in Southern California?
While tropical storms have, rarely, reached Southern California, there is no record of a hurricane ever reaching the coastline there. A deadly tropical storm took 45 lives in 1939, and Tropical Storm Kathleen caused lots of flooding on September 10, 1976.
What other countries also have weather satellites in orbit?
Currently, the following countries have weather satellite programs: Japan. Russia, China, India, South Korea, and Europe, European Space Agency. Japan launched its geosynchronous meteorological satellite Himawari in 1995, but in 2003 it malfunctioned. And so NOAA permitted the Japan Meteorological Agency use of the older GOES-9 satellite. The European Organization for the Exploitation of Meteorological Satellites, EUMETSAT, operates what is now the second generation of Meteosat satellites. Europe launched its first weather satellite in 1995. And this second generation came online in 2004 with Meteosat 8. This satellite scans the entire globe every 15 minutes. China launched the Fenyun in 1990, and there have been several successors since then. That same year, Russia launched GOMS, Geosynchronous Operational Meteorological Satellite. The Indian satellite, INSAT, made orbit in 1990. And was used for both weather observations and communications. It was followed by INSAT 2 through INSAT 4 series, before the Kalpana 1 was operational. In 2002, the Kalpana 1 satellite is India's first exclusively meteorological satellite. South Korea's first weather satellite is the Communication, Ocean and Meteorological Satellite, COMS, which was launched in 2005.
What methods do farmers use to protect crops from frost and sudden freezes?
Frosts and freezes can prove to be a major hazard to crops, especially in warmer climes where such incidents are rare. Some crops, such as citrus fruits, are particularly vulnerable, and there have been many years where orange, lemon, avocado, and other such produce have been nearly wiped out in places such as Florida, California, and Texas because of a sudden frost. One method that has been used to protect crops is called a smudge pot. These are portable burners that create heavy clouds of smoke, which help to hold in warmer temperatures closer to the ground. Environmentalists do not favor this method, however, because it creates a lot of pollution. Another preventative strategy is to use huge wind machines. These giant fans blow warmer air downward onto the ground, circulating away the colder air that hangs low to the surface. Interestingly, farmers sometimes also coat their crops in ice to protect them from frost damage. Using sprinklers, they will spray the vegetation down, and, as long as the temperature does not drop below 25 degrees Fahrenheit, -4 degrees Celsius, the crops do better than if they are allowed to go unprotected from the frost.
What is POS?
POS is an acronym for Polar Operational Environmental Satellite. These are the successors to the TIROS satellites, and they are thus called the Advanced Television Infrared Observation Satellites, ATN or TIROS-N. Like the GOES, There are two POs operated by the U.S. Department of Defense's Air Force Space and Missile Systems Center in what is called the Defense Meteorological Satellite Program. The POs orbit the Earth at elevations ranging from 515 to 540 miles, 830 to 870 kilometers in altitude, with one crossing the equator at 7:30 a.m. and 1:40 p.m. Data is then transmitted to stations located at Wallops Island, Virginia, and in Fairbanks, Alaska.
How does El Niño occur?
The El Niño weather phenomenon happens because of the unstable interaction of ocean surface temperatures with the lower atmosphere of the tropical Pacific Ocean in processes that are so complicated even modern science does not fully understand it. The process has to do with worldwide dynamics of the ocean and atmosphere, including oceanic waves crossing the entire planet, currents, and global circulation of the atmospheric. About the only thing that scientists have concluded with much certainty is that neither sunspots nor volcanic eruptions seem to influence El Niño.
Does it rain in the Arabian Desert?
Located on the Arabian Peninsula and covering an area of some 900,000 square miles, 2,300,000 square kilometers. The Arabian Desert is, indeed, a very dry place, but rain does fall there. Some parts of this desert receive an average annual rainfall of a mere 1.38 inches, 35 millimeters. On occasion, flash flooding occurs because of rainstorms. The worst of these occurred in 1995, when a storm and high winds caused flash floods that killed 5 people near Jeddah.
Did air pollution originate with the industrial age of the 18th century and beyond?
No. Since before recorded history, when humans first discovered fire, people have been generating pollution. As people learned to burn coal, they were also subjected to sulfur dioxide poisoning. Indeed, even Native Americans such as the Hopi used coal as a source of fire and heat.
What is industrial forecasting?
Industrial forecasting has applications in economics, both local and national. Weather affects businesses, transportation, and consumer activity in a wide variety of ways. Predicting heat or cold waves, for instance, can help utility companies plan for surges in consumers' use of air conditioners and furnaces. Cities located in drier climates, such as Los Angeles, benefit from rain predictions that affect water reservoirs. Local governments, for instance, can issue water conservation guidelines in times of drought to prevent resources from being stretched too thin. The sports industry, a multi-billion-dollar market. Benefits from forecasts planning for rain, snow, or other harsh weather conditions. Forecasts of ice and snow can help transportation firms plan shipments. And even the fast food industry is affected by weather. For example, research has shown that people order a lot more pizza deliveries in cold and inclement weather. In short, industrial forecasting is of great interest to business and government, as it helps people plan for potential losses. Winter blizzards or hurricanes routinely cost local economies billions of dollars, or redistribution of resources.
What are pollution hotspots?
Levels of pollution are not consistent throughout polluted areas such as industrialized cities. For example, car emissions along freeways raise air pollutants significantly in adjacent areas. And air quality inside tunnels and parking garages is considerably worse because of limited ventilation. Other potential hotspots include areas, whether urban or rural, that lie downwind of factories and power plants.
What is the jet stream?
The jet stream is a band of swiftly moving air located high in the atmosphere, and affects the movement of storms and air masses closer to the ground. The currents of air flow from west to east and are usually a few miles deep, up to 100 miles, 160 kilometers, wide, and well over 1,000 miles, 1,600 kilometers, in length. The speed at which the air travels in the jet stream is over 57.5 miles, 92 kilometers per hour, sometimes moving as fast as 230 miles, 386 kilometers per hour. There are two polar jet streams, one in each hemisphere. The jet streams meander across the troposphere and stratosphere, up to 30 miles 48 kilometers high, and between 30 and 70 degrees latitude. There are also two subtropical jet streams, one in each hemisphere, that range between 20 and 50 degrees latitude. The subtropical streams flow between altitudes of 30,000 to 45,000 feet, 9,150 to 13,700 meters, and are even swifter than the polar streams, moving at speeds of over 345 miles, 550 kilometers, per hour.
Why is it more likely to rain in a city during the week than on the weekend?
Urban areas have an increased likelihood of precipitation during the work week because intense activity from factories and vehicles produce particles that allow moisture in the atmosphere to form raindrops. These same culprits also produce warm air that rises to create precipitation. A study of the city of Paris found that precipitation increased throughout the week and dropped sharply on Saturday and Sunday.
What is the low-level jet stream?
Seen in the central United States, low-level jet streams are airflows coming in from the Gulf of Mexico into the Central Plains. But they also occur as streams flowing from the Indian Ocean into Africa. Low-level jet streams occur at altitudes of only a couple thousand feet and can bring in moisture and warm air that creates severe thunderstorms and tornadoes. In the Central Plains, though, they only occur at night.
What is an indoor thunderstorm?
When the humidity is very low inside a building, static electricity can easily build up as people walk across carpeting, dragging their feet, and then touch a piece of furniture, a doorknob, or some other object. When this happens, a discharge of about 40,000 volts can occur in even a small spark jumping from your fingertips. Running a humidifier inside the home during winter can usually keep these indoor thunderstorms, a rather exaggerated term, at bay.
What physical evidence shows that the continents move?
Scientists have gathered plenty of evidence that shows the continents move over time. For example, the shape of the continents and their fit was determined by Sir Edward Bullard in 1965. He did not cite the usual continental shapes we see, but he measured the real edge of the continents, the continental slope, an area that shows a much better fit at the 6,560-foot 2,000-meter depth contour than at the shorelines of continents. Other scientists matched the continental geology on either side of an ocean. For example, the mountain belts of the Appalachians and the Caledonides are relatively similar geologically, as are the sedimentary basins of South Africa and Argentina. Another way to prove that continents move over time includes paleontology, in which similarities or differences of fossils on certain continents indicate a match. For example, there are similar Mesozoic-era reptiles in North America and Europe, a time when scientists believe those two continents were joined together. Similar Carboniferous and Permian flora and fauna are found in South America, Africa, Antarctica, Australia, and India. In contrast, no doubt after the continents were well separated, there is a wide diversity of organisms in the Cenozoic era.
Can the relative humidity ever be higher than 100%?
No. It was once theorized that when clouds are in a state called supersaturation, it was possible to have a relative humidity of slightly over 100%, but this has since been proven false.
What is nuclear winter?
A nuclear winter is what would follow a large-scale nuclear war. Radioactive particles, dust, and smoke released into the atmosphere would create a large cloud over the planet, blocking out sunlight and reducing temperatures worldwide. Plants and animals would die due to the extremely low temperatures and reduction of sunlight. An extended nuclear winter could cause the death of millions of people from starvation, cold, and other problems.
What are the National Centers for Environmental Prediction, NCEP?
Part of the National Weather Service, the National Centers for Environmental Prediction include the following centers: the Aviation Weather Center for monitoring weather conditions that could prove hazardous to airplane and space flights. The Climate Prediction Center is focused on how climate affects the country, as well as on short-term climate changes. The Environmental Monitoring Center is a research center studying ways to improve weather-related sciences, including climatology, hydrology, and ocean weather prediction. The Hydrometeorological Prediction Center provides rain forecasts for the upcoming week. The Ocean Prediction Center is responsible for issuing ocean weather warnings in the Atlantic and Pacific Oceans north of the 30th degree parallel. The Space Weather Prediction Center warns of weather conditions on Earth and in space that could put space missions at risk. The Storm Prediction Center keeps a watchful eye on tornadoes, hurricanes, and other hazardous weather within the lower 48 U.S. states. The Tropical Prediction Center monitors tropical weather systems within the United States, as well as surrounding regions.